shall go for the next problem now, which is problem number 3 in the lecture. And this one is telling that a light rod AB of length 2 meters is suspended from ceiling horizontally by means of 2 vertical wires as shown. One wire is made of steel of cross section 0.1 centimeter square and the other wire is made of brass of cross section 0.2 centimeter square. Young's moduli of brass and steel are 1.0 into 10 to the power 11 Newton per meter square and 2.0 into 10 to the power 11 Newton per meter square respectively. Locate the point C where a load must be hung to produce same stress and in part B same strain in the wires. So first part we will find out what is the condition for finding same stress, producing same stress in the wires. This is the figure here, a ceiling with the help of 2 wires, one steel and the other one is brass. A light massless rod is suspended horizontally. This rod is named AB. And let me write clearly, this is the steel wire and the blue one is the brass wire. The length AB is given to be 2 meters. So I shall call this length L and write here that L is equal to 2 meters given. It's further given that for the steel wire, cross-sectional area, I am using the symbol here, cross-sectional area A for steel wire, this is 0.1 centimeter square, that is 0.1 into 10 to the power minus 4 meter square. And similarly, for the brass wire cross-sectional area, that is A brass, this is given to be 0.2 centimeter square, that is 0.2 into 10 to the power minus 4 meter square. Now, they have also given us the Young's moduli of brass and steel. For brass, Young's modulus is 1.0 into 10 to the power 11 Newton per meter square, and for steel, Young's modulus is 2.0 into 10 to the power 11 Newton per meter square. Let me write it, this one in scientific notation, that is 1 into 10 to the power minus 5 meter square, and second one is 2 into 10 to the power minus 5 meter square. Okay. With the data, we have to locate the point C on the rod where a load must be hung to produce same stress. Suppose this point is taken to be here C and a load is hung from here. So if mass of this block is M, the force of gravity, load is acting downwards is mg. And suppose the distance AC measured along the length of the rod is taken to be x. We have to get the value of x with the given data to produce the same stress in the wires. So, as a force of gravity is acting to the point C, there must be 2 tensile forces acting on the wires. I am calling them as T steel and T brass for the steel wire and the brass wire respectively. If there is a force downward, there must be also a force of equal magnitude in the upward direction given by the ceiling, because the wires have been taken to be massless, and under these 2 tensile forces, a pair of tensile forces, each wire goes through an extension, that is stress and strain are both produced here. So, let us first find out in the part A of the problem that what is the formula of stress. Stress is given by the tensile force divided by the cross-sectional area of a wire. So, for the steel wire, sigma steel is given by tensile force acting on that divided by the cross-sectional area of the steel wire, is not it? Similarly, the stress produced in the brass wire, sigma brass, is given by the tensile force acting on the brass wire divided by the cross-section area of the brass wire. And since they have said that both the stress on the steel and the brass wire, they are equal, it follows therefore that T steel divided by A still must be equal to T brass divided by A brass. It follows therefore that the ratio of the tensile forces acting on the steelware and on the brassware, T steel by T brass, this is given by cross-sectional area of the steelware by the cross-sectional area of the brassware. Referring to the data given here, you can see A steel is this one and A brass is this one. So I might write it 1 into 10 to the power minus 5 meter square divided by 2 into 10 to the power minus 5 meter square. This ratio is coming out to be simply half. So we conclude that the tensile force acting on the steelware by the tensile force acting on the brassware must be having a value of 1 by 2. Now once we know this result, let us come back to the figure and see how we can locate x with the help of this.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.